Hi Colts, we're going to be doing readiness assessment number 5. We're going to do part 1, which is numbers 1 through 8. So question number 1, we have an inequality. I'm going to use a sticky note just to give us a little bit more space to work. And I'm going to get the x by itself as our first thing that we want to do. So we're going to look at, we have a 4x and we have 2x. And if we recall, it's easier to move the smaller coefficient. And so we have a positive 2, so the opposite of positive 2 is going to be negative 2 or subtract 2. So we're going to do it to both sides of our inequality. These cancel out. We're left with a 17. Now if you remember when we're doing inequalities, if we multiply or divide by a negative, we will have to flip the sign. But in this case, we just subtracted, so we haven't multiplied or divided by anything. We're going to do 4x minus 2x, which is going to give us 2x, and we have a minus 5. Then we're going to add 5 to both sides. We're going to end up with 2x greater than or equal to 22. To solve for x by itself, we're going to get rid of that 2 up front, so we're going to divide. And we're going to end up with x greater than or equal to 11 for number 1. Okay, moving on to number 2. Number 2 is going to be multiple choice, and it's saying which inequality is represented by the number line. So if you remember, we got to remember what represents open inequalities and closed inequalities. So when I have inequalities with the lines underneath, remember we include it, or it kind of looked like a guy with really tired eyes with wrinkles underneath, and he's yawning. And then when we have ones that do not have the wrinkles under his eyes, it is going to be our open circle. So in our case, at our negative 4 here, we need a closed circle, which means we need our inequalities that look like this. So we go down our multiple choice and we say, okay, this one has it, so that's good. We look at this one, doesn't, so it can't be B. Look at C, doesn't have it, so it can't be that one. And we look at D, so it has it. And then we jump over to our second circle. And in this case, we have an open circle, and it's going to be at the number 5. And because it's open, we're going to be looking for inequalities like this. So we go down here and we look, and we say, okay, that one has an open. And we already crossed off these guys. And we jump down here, and that's another closed circle, so it can't be D. So by process of elimination, our solution for this one is going to be A. Now if you remember, if you look at this, this is saying I want all the numbers that are greater than or equal to negative 4, and it's going this way, and I want all the numbers that are less than or equal to 5. Excuse me, just less than, no equal to, less than 5. Okay, we jump down to number 3. Again, we don't have a lot of space, so we're going to use a sticky note to help us, to give us a little bit of space to work with. Okay, and I'm going to rewrite our inequality. I'm going to do 1, our inequality sign 3x minus 2. Okay, and there are 2 ways to do this, and I'll show you both ways. We'll do it one way, and then I'll give you the option the other way if you like it better. Because there are 2 inequalities, just like we draw our lines through our equal signs, we're going to draw lines through our inequalities, but we have 2 in this case. Whatever I do on one of the sections of the lines, I got to make sure I do it on all of them. So I want to get the x by itself. So I want to get rid of this negative 2 first. So I'm going to do the opposite, which is going to be plus 2. So if I plus 2 in the middle, I have to plus 2 on the right side, and I have to plus 2 on the left side. So 1 plus 2 is going to give us 3. We have our inequality, then we have 3x. We have our other inequality, and then we have 15. Now to continue to get our x by itself, we're going to divide by 3. And what I do in the middle, I have to do on the 2 sides, and I have 3 divided by 3 gives me 1. And then I have a 5 on this side. So our final answer for this is that I want my x to be greater than 1, but less than 5. So the second way to do it, and if you're not interested in the second way and you feel like you got it, you can always just skip it, fast forward it to number 4. But for our next one, it's going to be, if I took the inequality and I just wrote it as 2, and I split it. Maybe you like it that way better. So as you go through, you would add 2, we'd go to solve it, and we'd end up with 3, inequality of 3x. Here we're going to add 2, we're going to add 2, we're going to have 3x, our inequality, and then 15, so our 3x is greater than 15. Then I would divide by 3, and I'd get 1, and then I'd have that x greater than 1. I'd divide by 3 here, and I'd have that x greater than 5. Okay, it might get a little confusing putting it together. Oh, my apologies. We switched up the inequality. So what happens when Miss Chandler goes too fast? I apologize. Now, if you look at these, you would have to combine them together, and we would have our x, our inequality, and our 1. Okay, but if you like the first way, you could just skip this part. Okay, moving on to number 4. We got to remember absolute value. What do we remember about absolute value? So absolute value, if you recall, is when we have those brackets, and say I have something that equals 5, and I would say, what do I plug in here that would make this equal to 5? If I plugged in a 5, well, the absolute value of 5 is 5. That would work. But I could also say that the absolute value of -5 is also 5. So in that case, 5 and -5 would work. The biggest thing for this is we have to remember for absolute values is they have to equal positive numbers. Okay, so if you ever get an absolute value equal to a negative, we're going to talk about that a little bit later, but you're going to know that it's no solution. Okay, so we're going to erase this. We got a little bit of space to work to do this question. So we have 2x minus 1 in our brackets equals 7. So the first way we're going to do it is we're going to just do it regular how we see it. 2x minus 1 equals 7. And our second way is going to be 2x minus 1 equals -7. So it's like saying we're going to plug in a 7 and a -7 into those brackets to give us 7 if we took the absolute value. So we always take it and we do the positive one if it's already positive, and then the negative one. So to go through and solve for this, we're just going to do our regular algebra. I'm going to add 1 on both sides. So I get 2x equals 8. I divide by 2, and I get x equals 4. Now a good indicator for this one is it says, like we know, we've seen a bunch of them that say select all that apply. That means there's going to be more than one solution for this one. So I'm going to add 1 again for this other option, and we're going to have -7 plus 1. So don't get confused, but this is going to make it a -6. Now we're going to divide by 2 on both sides, and we get x equals -3. So our second option, multiple choice, is going to be B for this case. Okay, we go down to number 5. Number 5 is similar, but instead of an equal sign this time, we're going to have an inequality. So I'm going to rewrite it down here so we have some space. Okay, so there's a couple ways to do this. A lot of you guys like to distribute, but I want to get rid of that -3 out front, just to make my life a little bit easier. So right now, my absolute value, I have some absolute value stuff on this left side, and right here I have a positive number. But I don't have the absolute value by itself. So I'm going to get the absolute value by itself, and if I get the absolute value by itself, and on the number on the other side is a positive, I can continue. But if the number on this side is negative, then it means it's going to be no solution. Nothing's going to work. Okay, so we'll get rid of some of our green circles. We're going to divide this by -3 because that -3 is outside multiplied. Cancels these out, so I have the absolute value of x plus 1. I multiplied in this case, I divided by a negative, so I'm going to flip my inequality, and I'm going to have -7. So in this case, because this is negative, it is not going to work. So we don't have to go any further, and for number 5, we get no solution. You just need to be careful right away. Don't assume if you see that this number is negative, that automatically is no solution. You got to make sure the absolute value part is by itself. Okay, going over to number 6. This one is saying which inequality is represented by the number line. So this one we have to go through and we have to solve it and see which ones give us -6, and 6 is our solutions. Okay, so if you were to do this first one, and you were to go through and solve this, and you added 4, you get x greater than or equal to 6. So 6 is good, and it has a closed circle, but I want greater than 6. In this case, we're not going greater than, so it's not going to be A. Okay, so we'll try another color. So let's do, for B, we're going to do x plus 4 greater than or equal to 2. So in this case, we're going to -4, and we're going to do x greater than or equal to -2. So that means we should have a circle here, and we would have greater than. So that does fall in between where our line is, but that's not where our circle is located, so it's not going to be B. So we're going to try C. So we're going to have the absolute value of x plus 4 less than or equal to 2. So notice every time when I'm going over here and solving it, I'm just keeping it just like how I saw it, but I'm getting rid of the absolute value brackets just to see if the first case works. If it does, then I have to go through and do the second one. So in this case, I'm going to subtract 4 on both sides, and I get x less than or equal to -2. Again, that would be like my circle here, but it would be going this way, which that is not one of my end circles. So this one's not going to work. So by process of elimination, you can say, well, I know it's D, but we can go through it just to even see part of it. I have x minus 4 less than or equal to 2. If I add 4 to both sides, I say I want x less than or equal to 6. So this is where it gets a little bit tricky, because we try it again, and we're going to say, see if I mischannel, I can get this guy to go away. Sorry, we had a little bit of a technical difficulty. So in this case, we're going to do x minus 4. We're going to switch our inequality, and we're going to say plus 4, plus 4. So then that would end up with our circle at positive 6. Okay. I apologize, we have some technical difficulties. Let me get rid of this guy. There we go. Still learning how to use the iPad. Okay, number 7. So in this case, in number 7, we got to find the equation of a function shown in our graph. And so we're going to say, all right, first thing we want to look for is our y-intercept. And we see right here, for our y-intercept, which is our b value, it crosses at 3. So remember in our form, y equals mx plus b. And a good way to know, do I need it in that form, is if you look down at our multiple choice options, they are all in that y equals mx plus b format. So we want to find ones with positive 3. So our options with positive 3 are going to be B and D. So that means we can get rid of C and we can get rid of A. So if we look at B and D, we see, okay, what's the difference between the two? And we have our slope, or our M, is 1/4 and 4. So a good way to check this is you find some points where they look like they hit evenly. And then you might say, well, it looks like it goes up 1 and only runs 2. But be careful, because down here on our y-axis, this actually counts by 2's. So if I'm running here, if I'm going from -8 to here, that's actually -6, that's 2 spaces. And jumping from -6 to 4, that's 2 spaces. So altogether, okay, it's going to be 4. But in our case, remember, we want our positive slope, so make sure we do it our rise over our run. So our first thing was it rose 1, and then we ran 4. So we ended up with a slope of 1/4, which would give us B. Okay, jumping down to number 8, says which function has a graph with a y-intercept of -4. So if you remember, you can put them all in the y equals mx plus b format. I want this b to be -4. And a good way to look at this, I'll show you with the first example, so you don't have to go through as much steps with all of them, is the y, the coefficient with the y is going to affect that value. So if we look at option A, we're going to say 2x minus 4y equals 8. So to get the y by itself, I can subtract 2x, I could subtract 2x, and I get -4y equals -2x plus 8. Then to get the y by itself, I divide by -4. These cancel out, and I get y equals, now remember our butterfly, I have a negative over a negative, which gives us a positive. We're going to reduce that fraction to give us 1/2 x. And I'm going to do my butterfly again, and I'm going to have 8 divided by -4, which is going to give me -2. So my b in this case is -2, so a does not work. So a good way to look at this is I'm going to look at this constant here, and I'm going to look at this coefficient that's with the y. So if I did 8, let's not use a highlighter, use a regular one. If I did 8 divided by -4, that gave me my -2, which is the same as here. So if I look at my next one, for b, I have -4 and I have -8. So I'm going to do -4 divided by -8. Well, I have a negative over a negative, so that's positive, so automatically it eliminates it, and it also ends up being 1/2. So b is not going to work. If I look at c, I have a -8 divided by a -2. So right now we should say, okay, I have a negative divided by a negative, and that gives me a +4. So in this case, I want a -4. So let's see if this way even works. Let's try our last one. If I have an 8 divided by a -2, that gives me -4. And just to see it, we're going to take d and we're going to say 4x minus 2y equals 8. And if I wanted to get the y by itself, I subtract 4x, I subtract 4x, I get -2y, don't forget the negative, minus 4x plus 8. I put the -4x first because we want to keep in the mx plus b format. I divide by -2. Our -2's cancel, and I get y equals a negative divided by a negative gives us a positive, and 8 divided by -2 will give us a negative. So if I were to reduce this, I'd end up with 2x minus 4, which means that function d would have a graph with a y-intercept of -4. And that concludes Readiness Assessment 5, Part 1.